So the ship which is sailing to achieve its goal of decarbonization of Indian transport system has started its journey and reached one of its milestones, where we have covered the overall comprehensive view of and the objective of DTI project, and then ITF LCA project. Now it is time that we shed some light for setting a different set of direction from the beacon lights, where we look into the evidence-based policy researching, mitigation measures, data development in the Indian scenarios. So we have panelists as well as the speakers who are very experienced in this particular domains from academia and industry. Now I would like to invite our first speaker, Dr. Munish K. Chandal, who is a professor at Environmental Sciences and Engineering Department, IIT Mumbai. His research interests include climate and transport, greenhouse gas mitigation, sustainable development, and water energy mixes, and solid waste management and waste to energy. Professor Chandal received BTech degree in civil engineering from NIT Hamipur and PhD in environmental engineering from IIT Delhi. He was assistant professor at civil engineering department IIT Roorkee before joining IIT Bombay. Before that, he was a research scientist at Duke University, USA, and postdoc with École des Mines de Nantes, France, and Dalhousie University, Canada. Professor Chandal has more than 16 years of research and teaching experience. He has published more than 80 research publications in different journals and conferences, and has been associate editor of 2 journals. And he has been extensively working on the development of life cycle inventory databases that are very specific to the Indian context for the past 8 to 10 years. So now I would like to invite Professor Munish K. Chandal to present his talk on urban transport emissions under current and alternative mitigation policy scenarios for the Mumbai metropolitan region. Welcome you, sir.
Okay, can you see my slides, please?
Yes, put it on slideshow.
Okay, is it visible?
Yes, yes, it is.
Okay, thank you, Professor Dubey and others who have organized such a wonderful webinar. In fact, when Professor Dubey asked me to speak and attend this webinar, I was a bit confused because the major transportation work we did and we published was kind of 2 years ago. So now I can collect from where why Professor Dubey called me. We worked on climate and transport issues for last 7-8 years. One project was what we call Climate and Transport, funded by Research Council of Norway. And in that, the objective was to look into the mitigation as well as adaptation strategies for the cities and make a framework for Indian cities, and which can also be used for developing countries. So it was a consortium project, and the cities which we studied were Bangalore, Delhi, and Mumbai. So in this today's webinar, I will talk specifically about the transport emissions under current scenario and how they will be influenced by alternate policy scenarios. So I will only be talking about greenhouse gas mitigations and will not talk about other things in this one. So for example, we wanted to study that what is the overall greenhouse gas emissions coming from the transportation sector in India in different cities and how it will change in future, and how it may be reduced if we have some kind of what we call policy scenario. So what we did, we looked into the base year travel demand model, which was for 2005. And then we projected the travel demand for future 2030 and 2050 under different scenarios, and then estimated the emissions under those scenarios. We did different kinds of emissions, including PM, NOx, and carbon monoxide as well. But today I will only talk about carbon dioxide. So this is how it looks, the framework. Base year travel demand model was 2005, and then under business as usual scenarios, forecasting the travel demand for future for 2030 and 2050, and then looking into 5 alternate, you can call alternate or otherwise just policies, which might be helpful in reducing the greenhouse gas emissions. And also looked into when we are integrating more than 2 policies together. So I will talk about all these policies quite a little bit later. As many of you will be aware, we used what we call this 4-stage travel demand model, and for the forecast also, the base year data available for us was from the CPS study done for MMR, and that's why we took the base year 2005, and then we validate the model and then did all the 4 stages of the 4-stage transport model, and after validation we did the forecast. So I will not talk in detail about the model because that's a little bit too specific to the transportation specialist. But what were our different scenarios, and so that I can give you a sense that how the emission will change. So for example, this first scenario was called business as usual scenario. So where we projected population and employment, which was again based on the CPS, and also incorporated proposed road and railway infrastructures and addition of new transit modes as and when they are planned. And for example, we can see the population forecast, then the employment forecast as well. And this again was based on the CT study. And then you can see very clearly how under this scenario, this mode share would change. For example, if you see here, quite interesting is mode of train, which is around 52% mode share. And in future, it will decrease because the metro share will increase. Similarly, there was found some, again, decrease in the bus share as well. And then from 25, 26 to 9, and then to 7%. Cars increased, 2-wheelers first increased, and then these decreased as a mode share in future. So this is how the vehicle kilometer travel would increase, and you can see, as expected, there is a considerable increase in internal as well as external vehicles. I would say that it's around 6 to 7 times in increase from 2005 to 2015. Now, then we looked into what we call mitigation policy scenarios. So under those, we investigated 5 scenarios. We modeled 5 scenarios. For example, first one is population redistribution. So in fact, this another study which was done for Mumbai for MMR, and in which that there was some different plan in terms of growth projection, which was different than the CTS. And there were some new growth centers proposed in that plan, in that regional plan. So what we did is we assumed that again there will be a what we call population redistribution. That means as the population of be a business as usual scenario would be there, but then there will be redistribution. And that redistribution is based on because those 4 business center which is proposed in this Mumbai regional plan that was given higher population and higher activity. And after that, the policy 2 was integrated land use, but having low population, because as I mentioned, so it's a typical regional plan scenario in which we have lower population increase as suggested in that. Also, all the 4 regional centers which are proposed to be developed for the more business as a business hub in future. So, for example, if you see in policy 1 in BAU, we have population increasing from 34 million to 49.3 by 2050, whereas in policy 2, it is kind of on the lower side, 28.2 and 33.6. as well as the business activity also is a little bit on the lower side. As compared to the business as usual scenario in this policy framework, there was some new projects, new transport projects, which were envisaged and were supposed to be coming in by 2030. So, for example, some new suburban rails for metro, some tunnels, some bridges. So we assume that they will come in the place in scenario. Then in policy 3, this policy 3 scenario basically reflects improvement in public transport infrastructure. That means that we assume that there could be some dedicated bus rapid transit systems on the 4 major multi-lane highways, for example, JVLR, Western Expressway, Eastern Expressway, and Eastern Freeway. In a sense, there will be an increase in public transport by buses. So that was dedicated to those 4 corridors were model in this policy scenario. So then there was the 4th policy scenario was if we have better travel demand management, which essentially means that we discourage private vehicles in different ways, having higher registration cost, increase in fuel prices, increase in parking charges, and introduction of congestion pricing, etc. So what we did is we have 2 alternate sub-scenarios, I would say, and in which we assume that especially in Greater Mumbai part, there will be high parking charges and there will be congestion pricing for private vehicles from a particular time to a particular time. So what we assumed is that, for example, the cost will increase, operating cost would be increased by around 60% in Greater Mumbai as compared to the business as usual scenario. And similarly, we assume that there will be in the alternate scenario, policy 4B, there will be increase in vehicle operating cost of all private vehicles in whole MMR by 10% as compared to the VAE. So that means by having a congestion pricing and additional parking prices, we will be having a little bit discouragement or the private vehicle use will become expensive. Then the 5th scenario was improvement in technologies. So first thing we assumed is that there will be penetration of electrical vehicles. 5 years ago, it didn't look that realistic, but today this scenario looks pretty realistic as we are moving a lot on towards electrical vehicles. So our assumption was 40% share of electrical vehicles among all 4-wheelers, which means cars, taxis, and buses, and 3-wheelers by 2030. And it would increase to 100% by 2050. And then 80% of electrical 2-wheelers by 20 will be, or all the 2-wheelers out of that 80% would be electrical vehicles, electrical 2-wheelers by 2030, and which eventually will increase to 100% by 2050. So this was the electrical vehicle scenario I was saying. We also integrated some of these scenarios. For example, we made policy bundles. One was on incorporating policy 3 and 4. And then policy bundle was having policy 2, 3, and 4 put together. Now, if you see in terms of the BKTs, this is the bottom one is for 2030 or 31, and the top one, light green, is for 2050. So you can see, for example, as compared to business usual, bundle 1 and 2 has reduction. Policy 2 has reduction because one part is that this is a lower population scenario. Policy 1 is kind of giving the highest vehicle kilometer travel. So that means it's not a great way because there was a couple of things which we model, high population and unrealistic or uneven redistribution of the population. So then the question was to estimate the emissions. So what we did is we took for internal combustion engines, we took the emission factors from RAI, and we also considered the vintage of the vehicles. So The reason is because, for example, it's like even in 2030, let's say the most of vehicle will not be purchased in 29 or so, but there is a kind of a distribution where there will be around, I don't remember exactly, but like half of the vehicles maybe 7 to 8 years old. So we took that kind of consideration, and based on their age, etc., we estimated the emissions for different types of vehicles. For electrical vehicles, we calculated emission factors, and we also estimated electricity grid mix emission factors, considering, for example, the forecast for different under different scenarios. So, for example, because in electrical vehicles, the whole thing or the major thing is that how we produce electricity. So in business as usual scenario, we took this approach, and the study done by IEA, which presents the electricity generation scenarios for India up to 2014, and then we took it further and estimated to 2050. So you can very clearly see here, for example, still by 2050, the major electricity generation still would be from coal, and a good amount will be from the gas itself. So that was business as usual. And we also estimated these emissions from electricity grid by assuming that what could be the other possibilities. So, for example, one hypothetical scenario was that if we produce all electricity from renewable resources, 100%, or if we go half by half, so half by half, it looks more realistic. And then, what if we do not move at all towards renewables and only have non-renewable around 100%? Again, not so realistic, but just to give a sense that what might happen if we do not move or decarbonize our electricity generation. So then, based on that, we have CO2 emissions and other emissions under different policy scenarios. So first, the bottom one is 2030. So for example, under the AU, we would have around 8.5 million tons of CO2 emissions per year. And if we have VAU scenario with electrical vehicles, it's gonna be some reduction, 0.5 kind of reduction. But if we, under scenarios, for example, where we have high electricity generation, at least half of it from renewable, we have considerable amount of reduction. Same is the case for example, for 2050. But 2050, you can see there is a huge reduction in terms of the overall greenhouse gas emission if we have high penetration of or what we have policy 5 scenario, where we have a good amount of electrical vehicles. And if we add it further, and if, for example, by 2050, which looks, it is also possible to have all energy, all electricity from renewable. So we can reduce our emissions from around 17.4 to 7 million tons. In half by half scenario, it's around 12.9. So that's a considerable amount of reduction. And interesting part is that if we do not go electrical vehicles, the policy scenarios change in other policy scenarios do not influence that much the emission reduction. The reason is because there is a lot of saturation, I would say, and there is the bandwidth is too low to move from one component into another. But electrical vehicles with renewable can really make the difference. Also, try to understand the emission intensity. For example, this is for and emission intensities based on CO2 in tons per year per crores of GDP for MMR. So you can see, for example, in 2030 as well as in 2050, our emission intensity will certainly decrease as compared to 2005, which is quite high here. We will be having a very low emission intensity in the future. So what we could conclude from this study, that electrical vehicle policies can have significant impact on the reduction of CO2. And I didn't show these results, but there are some scenarios where, especially in the EU scenario, there could be overall increase in PM 2.5 or NOx emissions because of our major electricity production is from coal. But please remember that also will be far away from, or at least a little bit away from the city. So health-wise, it still is going to be benefited. And the most plausible scenario, which is in which we will have half of the electricity production from renewable, that looks quite possible now. It would be the most possible one, and it certainly would be having a considerable reduction in the greenhouse gas emission. Similarly, as compared to 2005, there will be reduction in emission intensity, and it is also true for all scenarios in 2030 and 2050. So this study was funded, of course, by Research Council of Norway, but it took help from many people, including Professor K.V. Krishna Rao and other professors from Civil Department, and some of the data and information was given to us by MMRDA and other corporations in Mumbai and other. So, and then Professor Dixit was also co-PI in this project, and several students worked with me, Ishant Sharma, Rashiri, Sudhir, and some of them are either finishing their PhD abroad or are still in the end stage of their PhD, or a couple of them completed their PhD with me on this. So thank you very much. In addition to this, with respect to climate and transport, we also studied the impact of climate change on the transportation infrastructure for Mumbai, especially Mumbai is flooding prone, and looking into how the transportation behavior might change. And we also did some life cycle analysis on biodiesel and on ethanol production. At least diesel paper is in public domain, so anyone of you can see it. So with this, I would like to thank Professor Dubey and the team for giving me this opportunity. Thank you.
Thank you, sir, for your valuable insights on the developing the policy scenarios and mitigation measures for the Indian context. So we'll be taking up the questions during the panel discussion. So we'll be moving forward to the next speaker.